Now let's look at how the CPU can perform calculations using a process known as the fetch, decode, execute cycle. Here we have a representation of a CPU and RAM. The registers are also shown, where data can be temporarily stored. The program counter starts at 0000. This means that the first address in RAM that the computer will look for an instruction is at 0000. The computer needs somewhere to store the current address in RAM that it is looking for. This is what the memory address register is for. 0000 is therefore copied into the MAR. A signal is then sent down to the address bus to the RAM. The control unit sends out a memory read signal, and the contents of the address 0000 are copied through the data bus to the memory data register. As the contents of address 0000 is an instruction, it is copied into the instruction register. As the first instruction has been fetched, the system is at the end of the fetch stage of the cycle. The program counter can be incremented by 1 so the system is ready to read the next instruction. Now the instruction needs to be decoded. It is sent via the data bus to the control unit. Here the data is split into two sections. There is the operation code or opcode, which in this example is the first 4 bits. This is the command that the computer will carry out. The second 4 bits are the operand. This is the address in RAM where the data to be operated on is stored. The control unit can translate opcode into instructions. So here the control unit translates the opcode 0101 into a load from RAM instruction. Now the command will be executed. The operand is copied to the MAR, as this is the address of the data that needs to be loaded. The data at address 0100 is then fetched from RAM and then passed up the data bus to the MDR. As it is not an instruction but simply data, it is then passed to the accumulator. This is a complete fetch, decode, execute cycle. We'll run through the next cycle a little faster so that you can see the entire program being executed. The instruction opcode and address operand is placed in the IR and the PC increased by 1 again. Now the instruction is decoded, while the address of the data is to be acted on is placed in the MAR. The new data is fetched from the address and eventually ends up in the accumulator, along with the results of the previous cycle. To finish off this stage, the 2 values in the accumulator are passed into the ALU, where they can be added together as was instructed by the opcode. The result is then placed back into the accumulator. So that's a second cycle complete. The last cycle is for the instruction at 0010. It uses the opcode 0011, which is store, and the operand 0110, which is the last address in the RAM shown. So this cycle takes the results of the addition in the accumulator and stores it back into RAM.